So I would like to invite Mr. Paul Ellis. He's the CEO of Electron. He's going to be talking about energy, the use cases, and also Sankalp Shangri, the asker of last question. So he is the founder and CEO of Lala World. So you're welcome. The stage is yours. Thank you. And here's the pointer.
Thank you. Well, good morning. My name is Paul Ellis. I'm going to talk to you about the blockchain in the energy industry. My background is actually in financial services, so let me just try and connect the two and tell you a little bit about why we're going there. So hopefully we'll get that back up in a second. There's some slides I'd like to show you. So with that introduction, the financial services market, which I think is where many of the people here come from, is a highly competitive, very valuable, highly regulated market that operates on a shared infrastructure. The energy market is a highly competitive, highly regulated market, hugely valuable, that also operates on a shared infrastructure. And if you look and see where blockchain is being deployed in the financial services market, it's all about the shared infrastructure. And it's exactly the same thing in the energy market. So what I'm going to try and do is build up a picture for you of where the opportunities are in the energy space and tell you a little bit about what we're doing. If we can get that. Press it forward. 2 minutes. Oh, it's warming up. Okay, I beg your pardon. Okay. So we see three key elements where the shared infrastructure could benefit from blockchain in the energy space. The first one is what we'll call asset registration, and I'll give you an example of a real-world application in that in blockchain. So by that we mean things like where are assets located, where is this renewable generation facility actually physically located, what practical properties does it have. The second main area is in trading and transactions. There's a lot of commonality with the financial services market in that area, but there's also a number of differences. And I'll describe what we're doing in that and again how that specifically changes. And then finally in the area of data. Data is a very important feature of the energy markets, as it is in financial services, but it's one in which traditionally data has been siloed. Data is not accorded the value which it is due. It tends to be owned by data intermediaries, and as a consequence, it's left either sitting in a silo or it's not being monetized to the extent that the owners of the data should get. So I'll talk a little bit about where we are on data. And I think what's interesting is all of these are connected. So we're seeing IoT devices coming along. They're going to be generating data, but actually, where are they? So we'll talk a little bit about that. So let's start with asset registration and what's going on in that space. I'll be very specific in this because that's what we're trying to do. We're trying to get this to monetize reasonably quickly. In the UK energy market and a number of other energy markets worldwide, there is competition amongst different suppliers. In order to know which supplier currently supplies energy to any particular supply point, i.e. a meter, you need to have some form of asset registration or some form of registration process for that. In the UK, that's going to be called the Central Registration Service. And it's very important. Because without that, you can't do all the settlement and billing processes that come off the back of that. The current architecture for that is very old-fashioned. It's actually pre-internet, although it was actually put in place post-internet, but it's all pre-internet technology. It takes something like 17 days to switch suppliers in the UK, partly because of the way in which this infrastructure has been set up. And it's a highly expensive and uncompetitive place. So it's an attractive area for us, particularly because there is a tender, or will be very shortly a tender out for replacing this central service. So this is an area of focus for us. But it's not actually just registering supply points, potentially. If you've built an asset registration platform, you can be putting other things onto that. You can be putting, for example, renewable generation. You can be putting on flexibility, i.e. the ability to respond to turn down your energy consumption. That's a very interesting market as well. There's no real central register for that. So it's interesting, and it has opportunities to be extended. We can go on to the next one. So we built a central registration service. We put 55 million meters, which is roughly how many there are in the UK, and 63 suppliers, and we wanted to say to ourselves, actually, could this scale, could this work on a national scale? And the short answer is, it can. It can run, and this is using an Ethereum blockchain, using proof of work, a private consortium blockchain, using proof of work, and that will switch something like 20 to 30 times faster than the best projections of where we'd like to see the rates of switching between suppliers. So what we found in actually doing and trying to implement this is that blockchains are perfectly capable of handling these kinds of asset registration platforms. Okay, so why might we want to do that? Well, better, cheaper, faster is the first key thing that we would like to see. We believe that blockchain platforms, by removing the central intermediary and by providing a platform upon which effectively people can cooperate but also innovate without having to go through some central body to approve that innovation, is hugely powerful. And it means that you can actually offer these services at a lower cost and a lot faster. It also opens up some interesting questions about access from the regulator onto platforms. And I think this is something which it shares in common with the financial services industry, because being able to see what's going on and being a privileged party potentially that not only licenses or authorizes the existence of certain parties, certain smart contracts on the platform, these things provide a great deal of value which is not currently capable of being done. Okay. So why is it important? What's so big about a platform that links suppliers to meters, and why do you need to keep that? So the thesis is essentially this. Currently, the situation is that people are using mobile phones. So there's really a removal of these fixed phone lines into premises means that the only fixed endpoint in the country, typically, that is registered are energy supplies, that and water. And the water industry is way behind where we are on the energy supplies. So this is really quite interesting because it provides you with a KYC and know your customer for every single endpoint in the country. And what's going to happen over the next 10 or 15 years is we're going to see an explosion of IoT devices plugged in behind those endpoints. And those IoT devices are going to be generating data and wanting to do involved in transactions. And both of those are pretty interesting if you have a way of KYCing that. Because otherwise, how do you know it's a washing machine that's ordering that washing powder that belongs at number 33, whatever the street is? You don't. And a KYC based on a blockchain platform put around the infrastructure of energy is a very solid way of building that. Okay, let's deal with the next main use case. For those of you who don't know, the energy system is really in a very interesting state right now. The whole energy market is changing. It's traditionally been a very slow to change, top-down organization, run really with huge generation at the top end, system operators who balance the system, all the way down through distributors, and then finally to the distribution endpoints, the meters and the supply points. That's changing dramatically because the advent of solar power and renewables has grown something like 10 times faster than anyone predicted, even as short as 5 or 7 years ago. So there's been an explosion of local distributed generation. And that's causing big problems, or is capable of causing big problems. Because first of all, nobody really has a good handle on where this stuff is. It's connected at the distribution points rather than at the transmission level. So that's causing issues and problems where there are effectively capacity issues locally on the distribution network. And then throw into all of that the advent of electric vehicles, which consume something like 30 to 40 times the energy that a house will consume. And you can see that you have a lot of strain and stresses building up. and a system that's very different from the one that's actually been implemented. So the energy market is changing dramatically, and it's changing in a way that requires much greater collaboration and cooperation. And of course, that's the perfect place for distributed ledger technology, blockchains. Let me briefly talk about the duck curve. What we see on this is basically the net renewable demand. By renewables, I mean obviously solar and wind turbines and so forth. After that has come into the system, what is the demand on the rest of the system? So what do the coal-fired power plants have to produce? What do the gas plants, the hydroelectric plants, and so forth? And what this shows, this is as time it goes on, and as we project into the 2020s, what's happening, this is the hours of the day here, and this is the net demand here. What's happening is that as more and more renewables come on, the actual demand for traditional energy is dropping in the afternoon dramatically. But then you shoot up to a peak in the early evening. And that's causing a lot of problems. A lot of stresses are going to come about because of that. And there's really two ways that you can deal with that. Either you build a lot more power plants, which cost a lot of money, but they're pretty uneconomic because you can't use them in the afternoon. They're not 24 hours a day anymore. Or alternatively, you have to find a way to get people to turn down their consumption. And that's something called demand-side response. It's a very interesting market, and it's one that really has just started relatively recently, which is going to become hugely important as a way of managing our energy. So let's call this flexibility, the ability to ask people to turn down their consumption. Right now, something like 5% of all the activities in balancing the system come from demand-side response, from getting people to turn down. We'd like to see that, the system operator would like to see that closer to 50%. So there's a huge growth opportunity in demand-side response coming. Right now, it's a totally bilaterally traded market, just between a couple of parties, and very specific parties at that. It's not transparent, it's opaque, and there's a requirement for a huge growth in that. So that's the second main area that we are focusing on, is using a blockchain to provide the incentives for a single pool of liquidity to operate a trading operation in the demand-side response market. And this is actually quite an interesting market in some ways, because unlike the financial services market, where if I buy a bond, I own it, you don't, in the case of electricity, for example, numerous parties to collaborate. So the benefit from me asking to turn down can actually be shared by a number of parties who don't have to own the whole thing themselves, but can contribute to it. So it's something called a collaborative trade. So the platform that we have built in the demand-side response market is a collaborative trading platform that allows multiple parties to come together to bid collaboratively for demand-side response action. I won't go into the details of how we do it, but if anyone's interested, I'm around, so please come and ask me. Oops. Okay, so why should we do this on a blockchain? Well, the first reason is because we see the blockchain effectively as being the lowest cost potential deliverer of this. And we're not trying to make money out of the blockchain itself. We think the value comes from the services you add on top of the blockchain. It's like the internet. You need to build the internet first, and then you go and put the eBays and the Amazons and so forth on top of that. It's exactly the same idea with the way in which we're approaching this. So the trading platform itself will be run at the least possible cost. And we have a number of ways in which we guarantee that that happens, not least by providing competitive consensus nodes to be able to deliver that, and certain off-chain functions that also deliver that. So by running it at the lowest possible cost, you provide the guarantee that you're going to be the single pool of liquidity, because that's what you need in order to assemble collaborative trades. So first and foremost, that's the reason why we're focused on that. Let me move very quickly on. I'll just give you the last one. Is that working? Okay. Finally, let's talk about data very briefly. What's the problem with data? Well, there's an asymmetry problem. I can own some data, but unless I can see where that data is sitting in a population of other data, it doesn't become particularly valuable. I need to be able to see it in context. And the problem is that then means that you need intermediaries to assemble that data. The issue with that becomes the fact that these intermediaries are extracting all of the value from that data. Consequently, one of two things happen. Either people effectively give their data away for free, Facebook, Twitter, or whatever, and somebody else monetizes it on their behalf, which doesn't really set up the right incentives for sharing that data. Or alternatively, and this is the sort of thing that's happening in IoT, is people just sit on that data and silo it. They don't make it available for other parties. So what we have in that space is a data platform that removes the need for data intermediaries to own effectively that data and to then extract the maximum value. So we do this with our trading platform, and it's probably a big deal for many of you in the financial services market. You realize that effectively every time you trade on an exchange, not only do you have to pay for the exchange price of executing the trade, but you also give away the data as well, and they go and monetize it. And often it's the biggest value line on their P&L account. So actually handing that capability back is another benefit that blockchain can bring, and that's what we're trying to do in the energy space. So I will leave it there. The data access platform is not as advanced as the other two platforms. With the other two platforms, very briefly, we have built consortiums around them, consortiums specific to the particular use case. So in the case of a central registration service, we have 20 different energy suppliers who are working with us towards putting in a bid for the central registration service and in other countries as well. And in the case of the trading platform, we have some large players in the energy markets, including the National Grid in the UK, who are the system operator, Siemens, and a number of other parties who we brought together as part of a commercial consortium to build this out and to have a production platform ready, we hope, within about 2 years. Great. That's it. So if anyone has any questions, happy to take them.
Hi, hello. Can you give an example of a real-life future scenario about the usage of energy and the blockchain together?
Well, that's hopefully what I've been trying to do here. So the first example is a central registration service somewhere in which you can register, let's say, the generation assets. Where are they? In the first few years that we were rolling out solar PV, nobody actually registered where this stuff was. And that's a big problem, because if you're trying to balance the system and you don't know where it's being generated and a big cloud's coming over or the wind has stopped blowing, you have a problem.
But how will this impact humans' lives? Can you give the scenario specific to that? How will this impact the daily life of people?
Because the energy bill is going to be less or lower. Your energy bill is going to be lower, and it contributes. So the second example, the flexibility trading platform, if you are generating less, you're producing less carbon. It decarbonizes. So it's decarbonization. It is providing a more, potentially providing a more robust grid because the actual generation is distributed and increasingly will be handled by DSOs, distribution system operators in local microgrids. And finally, it will be cheaper because without central intermediaries taking a cut out of every trade and the inefficiencies that go along with that, we have a benefit to the consumers.
Hi. Is the UK an especially good place to do this?
Is what, sorry?
Is the UK an especially good place to sort of...
Not especially. It's one of the places where there isn't a total monopoly on the generation of electricity and the distribution of gas. But there are numerous other places that have the same features. I'm not familiar with the situation in Turkey and how that works, but certainly across Europe, Germany, France, parts of Asia, certainly Australasia is a very competitive market, and North America.